All right, welcome again to another episode. This time we're looking at a warm up number 2. So we're going to be going through some multiple choice questions. We're getting ready for our CXC exam 2024. So let's see how these can actually help you in your preparation. So question 1 says sulfuric acid is a strong acid than ethanoic acid, which is acetic acid, in aqueous solution because now the strength of an acid is based on its capability of being able to ionize, break apart in the respective ions. And so D would be your answer, a weak acid ionized partially. So ethanoic acid is a weak acid, and so it will break apart partially into the respective ions. When we look at question 2, it says, which of the following is not a normal salt? And a normal salt, overall, a salt is a acid in which the hydrogens or hydrogen, all of it or some, have been replaced by a metal or ammonium ion. So a normal salt will have all the hydrogens being replaced. So we're not going to be seeing any hydrogens in that. And so definitely A is not a normal salt because we're still seeing the hydrogen. So sodium hydrogen carbonate is actually an acidic salt. We know that what makes a compound acidic is the fact that it produces the hydrogen ions in solution. 3. A solution has a pH of 1. And right away, we know that in terms of the pH scale, which ranges from 0 to 14, we have a situation where from 0 to 6.9 would have been acidic, 7 is neutral, and then beyond 7 you have the basic solutions. So once we hear that we're dealing with a pH, a solution of a pH 1, we know that that is an acidic substance. That's an acidic solution. And so when an acid reacts with a metal, what would it do? It would produce hydrogen, right? So when it reacts with a metal to produce a solution of 10, no, it neutralizes a solution of pH 4. Now a pH 4 will also be an acid, and an acid can have neutralization. You basically get neutralization when you have an acid and a base. It reacts with hydrochloric acid to produce salt and water. No, again, those would have been two acids. And so that's not the case, right? 4. It says, which of the following substances is the oxide of a metal? And so we know that base are really oxides of a metal, right? Which of the following is an acid salt? And as we said earlier, an acid salt, you'll see the presence of the hydrogen in the salt. Not all of it would have been replaced by the metal. And in C case, the metal would have been sodium. So you still have some sodium. And of course, this would be coming from sodium reacting with sulfuric acid. And so we still have some hydrogen present right there. So sodium, right? Hydrogen sulfate is the name of that salt. So 6, ethanoic acid is a weak acid because it's a carboxylic acid. Yes, but that's not the reason why it's a weak acid. Does not irritate the skin. That's not why it's a weak acid. We said that acids are weak or strong based on the ability for it to ionize. So ethanoic acid is a weak acid because it doesn't ionize completely in water. It doesn't break apart in the respective ion. So the ethanoate ion and the hydrogen ion, some of them will form back into the acid itself, and so it's very weak. It's not providing that high, ions in the solution. Question 7 speaks to a little bit about formula writing, ammonium carbonate. And when we look at these, we want to basically deal with the concept. We said that ammonium is NH4, the ammonium ion, NH4 plus, and of course, the carbonate ion, CO3, and we have a 2 minus, right? We said that when we are writing that of a ionic compound, we write back the symbol of the cation. The cation is the one with the positive charge. And we basically look at the magnitude of the charge for the anion, and there's a 2. Now, since there's a 2, this is what we call a polyatomic ion. And a polyatomic ion, in order for us to indicate that we have more than one, we basically have to place it in brackets, parentheses, any one of those terms you want to use, and then that is what we would have obtained. Finally, we write the symbol of the anion without the charge, and so we end up with this. And so when we look at this, the answer would have been C, right? Phosphate, yes, the phosphate ion is the formula, or they said the formula is for the phosphate ion. What is the formula of calcium phosphate? Calcium is element number 20. And one of the things that you want to do with this information, again, we know if it's 20, we know it has the atomic number 20. And in terms of the atom, we know that calcium will basically be placed in group 2. So if you look at the electronic configuration, it is 282. So by doing that, we know that the calcium as a student is Ca2 plus. And then of course, we're looking, you were provided with that of the ion, the anion, the phosphate. And again, we have just done an example. So we know we start with the cation without the symbol. Look across on the magnitude of the anion, and that's what we're going to be placing as a subscript. So we end up with the 3, right? Then we write the anion without the charge. So without the charge, we look across, there's a 2. Phosphate is also a polyatomic ion. And so one of the things that we want to do is to ensure, so this would have been a subscript, guys, because I'm changing that, it kind of threw it off. So we basically have a 2 there, and if I can use that, would have had a 3. So the answer would have been A. So writing ionic compounds and formula, we should be able to do that. So question 9 speaks to Which of the following salts can be prepared by mixing two solutions and then filtering? And if you think to yourself, you know, in terms of making the salt, this sounds like a insoluble salt. That's how an insoluble salt is prepared. You mix two soluble solutions to basically get a precipitate, and then you filter and you collect that precipitate, and then you dry, and then you get your insoluble salt. Now, which of these salts in the list are insoluble? It goes back to your rules. We know that any compound that has in the nitrate, so all nitrates are soluble. So right away we know that 2 is out, and as we said, this is how we can do a little elimination. So anyone that has in 2 would be out. So A has in 2, C has in 2. And so we know that nitrates are soluble. We should also know that ammonium, so the group 1s along with ammonium are the cations that once they're in a compound, that compound is soluble. So ammonium carbonate is soluble. Now the rule is sulfates are soluble except barium or barium sulfate, right? Lead chloride and silver chloride are also exceptions to the rule about soluble chlorides. So here we have silver chloride. So 1 and 3, and so B would have been the answer. Now, this one speaks to the oxidation number. And we said that we can calculate the oxidation number using the formula. For all of these, we know that the concept is when we add the oxidation number of the elements within the compound, if it's a neutral compound, it should be equal to 0. So right away, manganese here, another rule is that oxygen has a oxidation number of -2 unless it is bonded to or in a peroxide. Hydrogen peroxide is the main peroxide that you'll get when you're doing the CXC level. So right here, if you do a little formula, and we call manganese X plus -2 would be equal to 0. And we know when we have the separate sign, so it's really X minus 2 equals 0. And if we want to get X by itself, we would basically add 2, and if we add 2 to that side, we have to do the same. And so in this case, it is actually a plus 2, not a plus 7. Right here, still a neutral compound. And so we again call that X. Let me change this. We would have called this X plus, we have -2, but in this case, we basically have 2 of them, right? And that would have been equal to 0. So when we work this out, manganese is a plus 4. In the other case, and we want to just show persons how we work them out. So the formula again, since it's M and 2, in this case, we would have basically said 2x. So 2x plus -2 and then we would have multiplied that by 3 and we add 0. So that we get -6, and we also would carry we would basically want to get the X by itself. We carry the 6, we end up with a +6, and then 2x we divide throughout by 2, end up with X by itself, and so we divide the 6 by 2, and this is a +3. So definitely it's going to be this one. So in this case, we have amongst it we have the potassium, and we know that the charge or the oxidation number is similar to that of a monatomic ion. So in this case, this is going to be a +1 plus X, X plus we have -2, and we have 4 of them, and we have equal to 0. So when we get this, we basically get -8. When we bring the like terms together, the positive one, we end up with -7. When we basically allow x to be by itself, we +7, and so we do it on both sides, and we would have actually +7 on the right hand side as well. And so D would have been our answer in terms of the oxidation number being a +7. Do remember that you would basically have some rules that will govern, and we have talked about a few of them a while ago, right? In a reaction between zinc and dilute sulfuric acid, water is formed and insoluble salt is formed, neutralization occurs, oxidation and reduction occurs. And so when we really look at it, this is really the concept of a metal, reactive metal, reacting with an acid. Acid plus metal, or acid plus a reactive metal, gives you a salt and hydrogen gas. So water is not formed, so A is out. An insoluble salt is formed. Now, when we think about the sulfate, we said that barium sulfate is one of those insoluble salts. Zinc is not one of them. And so, definitely, it's not an insoluble salt that is formed. It says it's a neutralization reaction occurs. And a neutralization is when you react an acid with a base or an alkalis. And so right here, we're not reacting an acid with a base or an alkalis, we're reacting it with a metal. And so that's not a neutralization reaction. So the answer is D, in terms of oxidation and reduction will occur. And if I can just quickly have this written out, we know that we have that plus the H2S SO4, right? And that would have given me, I'm using this equal sign to represent the concept of my arrow, reaction arrow. I know I get zinc sulfate, and that's the salt, plus hydrogen gas. And we said that if we can assign oxidation numbers, we know that the zinc right here, once it's an uncombined element, the oxidation number is 0, right? So we want to check this hydrogen, the oxidation number is a +1. We said that hydrogen has an oxidation number of a +1 unless it is bonded to a metal, and when that happens, it has an oxidation number of -1. We said that when we look at polyatomic ions, we would have had this same in terms of the oxidation number. So this is the charge of the ion. This is a -2. The zinc is now bonded as an ion, so we know that this is a +2, this is a -2, and of course, even though we have 2 atoms of hydrogen, we still call it not being combined with another element, and so this is 0. And when we look at that, we can track the oxidation number. We said we're really looking, we're reading just like how we read the reaction from left to right. We're seeing the oxidation state of the zinc moving from 0 to a +2. meaning it is being increased, and an increase in oxidation number represents really and truly oxidation. So technically this zinc would have lost the 2 electrons, that's why it became a positive 2, right? And so the loss of electron again is also oxidation. Right here, the hydrogen is a +1 and it's basically moving to a 0. What is happening to the oxidation number? It is basically decreasing, and we know a decreasing oxidation number is reduction. So D would have been our answer. So in which of the following does the hydrogen have a negative oxidation number? And even for this question, we just mentioned it. We said that the only time hydrogen would have an oxidation number is when it is coupled with a metal. And at D, it is coupled with sodium, so it's going to have an oxidation number of -1. So 13 speaks to which of the following methods may be used in the preparation of barium sulfate in the laboratory? Earlier on, we got a question regarding that, and we know barium sulfate is actually an insoluble salt. And so once you're going to be preparing an insoluble salt, we use the method of precipitation, where we basically take 2 compounds that are soluble. One that will give you the barium, so you can go barium nitrate, you can go sodium sulfate, which is also soluble, and then you basically react them to get that precipitate. Which of the following may be defined as the quantity of a substance which contains 6.02 times 10 to the 23rd particles of that substance? And that is the unit that we use to describe mole, right? The quantity of 1 mole of an atom of an element refers to, and we normally say that the element which combines completely with 12 grams of carbon 12. Methane burns in oxygen to produce carbon dioxide and water, a combustion reaction. What is the balanced chemical equation for this reaction? And so if we want to look at this, let me go up to all of these. We can basically examine, and we have a situation. Let's use this one as the example, and copy D, and we use it to assist us. We say that once we get a combustion reaction, it's an easy way to balance a combustion reaction. And so what we do is to basically look at the compound that is being burnt, the amount of hydrogen, we put half of that in front of the water. So we're going to be putting a half right here, which is half of 4 is 2, right? We look at the amount of carbons. In this case, we have 1, so we don't have to put a coefficient in front of the carbon dioxide. Now, when you look at this, the oxygen is the only one that is now left to balance. And so we see O2, so that's 2 oxygen, but we also place a coefficient here. So it's 2 times the one that is the subscript for the oxygen out here. So we end up with 2. So 2 and 2 is 4. How do we get 2 here, 4 on the reactant side? Bear in mind we would have had our arrow. We basically put a 2 here. Anyone that has this combination, I think C is the one that has that, and so C is the answer. What is the relative formula mass of magnesium nitrate? And we say formula mass because we're dealing with an ionic compound. And we said that what you do is to basically add the atomic mass of all the elements within the compound. And so we have magnesium. It's one atom of magnesium, right? So that's times 24. We get 24 grams. We also have the polyatomic ion, the nitrate ion in brackets. And please note that there is the 2, and that's why it's very important for you to be able to write the correct formulas, because if you do not, if you had MgNO3 only, then when you're working out something like the formula mass, you would not get the correct response. So we have nitrogen, and technically we're basically having 2 atoms. Each nitrogen atom has an atomic mass of 14. 2 times 14 gives you 28. In this case, we have oxygen and we have 6 oxygen. So oftentimes students misplace, and what they do is to not account for the 2 times the 3 that is there, just like in math, right? So each oxygen is 16, and 16, so that's 96. And when we add 24, 28, we get 96, we get 148. All right. Element X form an oxide XO that neutralize sulfuric acid. Which row describe X and XO? So element X is a metal, nature of oxide. XO is acidic. So we know that XO is actually, we said that if it neutralizes sulfuric acid, we know the only time we'll have neutralization is between an acid and a base. And if X is actually the element that it is forming a base from, then we know that it must be a metal. So it would have been B. So it's going to be basic and it's going to be a metal. Radioactive isotopes are not normally used in the treatment of influenza. So we use it to determine the age of fossils. We use it to treat cancer. We use it to power submarines, but we do not use it in the treatment of influenza, right? Which equation shows an oxidation reaction? And so we want to check. So carbon here is 0. The oxygen is also 0. Here the carbon becomes a plus 4 and the oxygen is a negative 2. And so the carbon is moving from 0 to a plus 4. What is happening to that? The oxidation number is increasing. So that's oxidation. The oxygen is moving from 0 to a negative 2. So the oxidation number is decreasing. Right? So we have both the oxidation and reduction happening here. For the calcium, we have 2 plus is going to still be a 2 plus. The carbon is going to be a 2 plus as well. Oxygen 2 minus. Carbon right here is going to be a plus 4. So right here is a perfect example, oxidation reaction. So where the carbon is moving from a 2 plus to a plus 4, right? So B. A farmer spreads calcium hydroxide on their fields to neutralize soil that are too acidic for crops to grow well. Because you know, crops are affected by the pH of the soil. The more acidic the soil is, the less chance of it to survive. Usually plants have a little range of about 6.8 to near neutral in terms of their um, pH to grow. Which ion neutralizes the acid in the soil? So you know that it's your OH ion because the calcium hydroxide will provide OH ion as a alkalis, and of course it's going to neutralize the H plus ion. 4 different solutions, J, K, L, and M, are tested with universal indicator. Which solutions are acidic? So when you look at the universal indicator, usually what this does is to give you a little bit more specifics in terms of the pH than the red or the blue litmus paper. The red and blue litmus paper just basically tell that if you're an acid or an alkali or a base. But with the universal indicator paper, it gives you a specific color change in terms of the range for one, and usually green and purple signifies, depending on the green, you can get from an area of neutral to alkaline, right? And of course, purple is basically a strong alkalis. The next, in terms of a red and an orange, those are usually indication of acids. So if you're testing those and you want to know if it is an acid, if you get, it would have been K and M that are acids. Particles are close in. We know that gases have particles that are very close, right? When sulfur is heated, it undergoes a one change as it melts, right? Further heating causes the sulfur to undergo a second change and form sulfur dioxide. Which two words complete the gaps, right? So one, when you heat it, it undergoes a change as it melts. And when you think of melting, you're thinking of a physical change. So it is either C or D. And then when it goes from sulfur to sulfur dioxide, that's a chemical change. And so C would have been the most appropriate response. A mixture is separated using the apparatus shown. We see the filter paper, we're seeing the filter funnel, we're seeing a beaker, right? What is the mixture? Is it aqueous copper 2 sulfate and aqueous sodium chloride? No, those two are basically aqueous, so both of them will actually come out in the filtrate that is here. No solid substance would be there. Aqueous copper 2 sulfate and copper. This sounds like it. Copper is a metal, right? So the copper is a solid, it wouldn't be able to pass through the filter paper. Copper and sulfur, no. Ethanol and ethanoic acid, no, because these two would have been miscible liquids and both of them will basically just pass through your filter paper. When we look at 27, it says mineral wool soaked in aqueous ammonia is placed in the apparatus shown. And you know, you recognize that we see the mineral wool soaked in aqueous ammonia, we see the damp red litmus paper. After 5 minutes, the damp red litmus paper turns blue. Which process led to this change? and we know that aqueous ammonia is a base. And so when this gas travels, the red litmus paper is basically turned to blue. That's what base do to a red litmus paper. Now, the only process that would have allowed for this, for the gas from the ammonia, from the wool, to reach to the damp litmus paper would have been diffusion, the movement. So here we have a high concentration, and so what would have happened is that the particles will move from a high concentration to a low concentration, heading in this direction, and eventually starts to react with that of the litmus paper. Which changes are physical changes? Melting ice to form water. So the change of state, burning hydrogen to form water, adding sodium to water, boiling water to form steam. So we know 1 and 4 are basically the two that deals with a physical change. We're changing state, melting and boiling. Which of the statements about paper chromatography is correct? A solvent is needed to dissolve the paper. No, that's not the reason for the solvent. Paper chromatography separates mixtures of solvents, and we want to be careful in terms of that. The solvent should cover the baseline. The baseline should be drawn in pencil. So again, the correct answer would have been the baseline should be drawn in pencil. You don't want to use any other substance that will basically, interfere with the separation. An example of a redox reaction is shown, and we see where this would have meant that zinc is reacting with a compound that contains copper. So the fact is, zinc, when you look at the reactivity series, zinc is higher, and they say that it's really a displacement reaction where the more reactive metal is able to displace the least reactive. So zinc is higher in the reactivity series than copper. So it says, which statement about the reaction is correct? Zinc is the oxidizing agent, and it oxidizes copper. Now, what is the oxidizing agent? The oxidizing agent is the one that is reduced, right? So the oxidizing agent in itself is reduced. And if that is the case, if we put in some oxidation number, the zinc right here would have been a 0. Right? And over here it becomes a 2 plus, it's a 2 plus ion, so it's going to be a plus 2. Its oxidation number is not reducing, it's actually increasing, right? So that A is out. Zinc is the oxidizing agent, and it reduces copper. Again, it's not the oxidizing agent. Zinc is the reducing agent. And so if it is the reducing agent, then it is being oxidized. And we did say that it's moving from 0. The copper is moving from a 2 plus or a plus 2 to a 0, so it's being reduced. So the zinc is the reducing agent and it oxidizes the copper? No, it actually, so where's D? Zinc is the reducing agent and it reduces copper. So the reducing agent is what causes reduction. And in turn, it is being oxidized. The chlorine gas dissolved in water, a reaction occurs. Which row in the table identifies the oxidation number of chlorine in the chlorine containing species? So when we look, so that chlorine again, it's by itself, and so we know right there and then it should be 0. So we already know that A and D is out. The second chlorine compound, hydrochloric acid right here, is a situation where it's going to be a -1, right? And in this compound, the chlorine basically adopts a positive one in this case. Because when you look at this compound, the hydrogen would have been a +1, and of course, if you want to work out that for the chlorine, it must have been a +1 as well, because the oxygen is a -2. And so we know that when we add all the oxidation number in a compound, then you should, in a neutral compound, it should equal to 0. So right there and then, it must mean that it is D. Which metal compound produces a gas that turns lime water milky when it is heated with a Bunsen burner? Now, when you think about lime water and milky, the gas that turns lime water milky is our carbon dioxide. In order for us to get carbon dioxide, we need to have a carbonate. So copper 2 carbonate is the compound. Which solution has the lowest pH? Right? The lowest pH. We are seeing ammonia solution, and we know ammonia is basically a base, and so that is out. Lithium hydroxide. Once we hear an hydroxide again, oxide, the oxide and the hydroxide of a metal are base, right? And so these two, A and D, are out. Which solution has the lowest pH? Is the strongest acid. So we know ethanoic acid is a weak acid because it doesn't dissociate completely in its respective ions, while hydrochloric acid is a strong one, and so C would have been the most appropriate response. When solid lead nitrate is heated, it decomposes, giving off nitrogen 4 oxide and oxygen. The balance equation for this reaction, one of the easy ways is for us to look at the oxygen. So we check the oxygen. So on the reactant side, basically we have 6 right here. 6 times 2, 12. So on the product side, we need to get 12. So we have 2 in this compound, we have 8, and then we have 12. So the oxygen would have been balanced. The nitrogen, we basically have 2 times 2, 4. We have 4. Lead, we have 2. Lead, we have 2. And so A, right away, A seems like would have been the correct answer. If we check any other one, let me do a check on B. 2 times 3 is 6. So we have, on the product side, we have 1, which is 3, and we have 5. So that's not balanced. C, we have 2 times 3 again, which is 6. We have 1, we have 4. So 1, 5, 7, unbalanced. So 6 and 7. Right here, we have 6, we have 1, we have 2 times, that's 5, and again 7. So A would have been the balanced chemical equation. the values of x and y respectively, and in the equation. So let's go back to the equation x and y. X and y. So we want to know the coefficient. When we look at this, here we have Br, right? So bromine on this side we have 6. 6. So we have 6 here. If we put 6 here, then we basically would run into problem and have 7. So here we must have 5. So y must have been 5. And of course, if y is 5, and then we have 5k and 1, so x must be 6. So y is 5, x is 6. Then we have our answer being B. Which of the following substance may be responsible for acid rain? Acid rain. Dust particles, radioactive fallout, carbon dioxide and carbon monoxide, sulfur dioxide and hydrogen sulfide. So sulfur dioxide and hydrogen sulfide is the answer. Those are the two that will cause your acid rain. Which of the following is not a method of separation? So we use paper chromatography to separate, filtration to separate, but we don't use melting. Melting is a change of state. We use distillation as well to separate. Fractional distillation separates liquids that have different, and this would have meant that they have different boiling points. And so miscible liquids that mix, for example, water and alcohol, can be used to separate in this method. The formula CaCO3 means calcium carbonate. Do we have 3 atoms of everything? No. Remember, when you see this subscript of 3, it is only speaking to the element that it precedes. So it's only 3 oxygen. So we have 3 carbons? No. 1 calcium atom, 1 carbon atom, and 3 oxygen atoms. So C is our answer. The liquid that is immiscible with water is ethanol, gasoline, milk, or vinegar. As we said before, when you think about mixing, you want to think about what are the two liquids. If it is two like liquids, then they're going to be mixing. So water is polar, ethanol is an alcohol, it's polar as well because of the hydroxyl group. Milk, likewise, the vinegar, and of course gasoline is the one that's really a organic compound. So gasoline would have been the response. All right, and so we end our warm-up 2, and we just want you to basically subscribe. If you want, you can contact us for classes, and we basically have our program where we can do our tutoring in CSEC Chemistry. Thank you.